We introduced ShapeR, a novel approach to robust conditional 3D shape generation from casual captured sequences. For a casually captured sequence such as the one on the top left, where the observer freely walks across the scene, we can run traditional scene-centric reconstruction, which can give decent metric geometry for all the surfaces observed. However, such scene-centric approaches have their limitations. For one, it produces monolithic geometry, meaning that everything is merged into a single entity. And since everything is a single entity, reasoning and interaction on an object level is quite challenging with such a representation. Because the representation capacity is shared across the entire scene, it can also be difficult to represent individual objects with a high level of detail. Further, even if you segment out one object in post-processing, these would be incomplete in the occluded regions. Here's another example where the same thing happens in scene-centric reconstruction, but with a different method and different 3D representation. On the other hand, there's the object-centric reconstruction paradigm, where reconstruction is performed on a per-object basis. Existing monocular approaches in this domain can sometimes struggle with the layout, the relative scale of objects, and maintaining correct shape aspect ratios in cluttered environments, in addition to being non-metric. To this end, we present ShapeR. Starting with a casually captured video sequence, such as the one on the left, we first pre-process the input to derive slam points and camera poses. An off-the-shelf 3D instance detector then identifies all objects within the scene. Using these multimodal pre-processed inputs for each detected object, ShapeR generates a complete 3D geometry. Applying this process to every object results in a complete object-centric 3D reconstruction of the entire scene. As the method can leverage slam points and post multi-view input, the resulting reconstruction is metrically grounded. And since the approach is object-centric, interaction is possible at an object level. The approach is inspired from the success of recent image-to-3D generative models, which work amazingly well for clean, unoccluded inputs, but struggle in the presence of real-world noise, clutter, and occlusions. We investigate how to make these approaches robust to casual inputs. At its core, ShapeR is a flow-matching transformer denoising a latent representation. It is conditioned on multi-view images and their poses, slam points, some 2D point prompts, and text. The model is made further robust by using a range of compositional augmentations across all the modalities, and the two-step curriculum learning approach further increases its robustness. Note that ShapeR has only been trained with synthetic datasets, yet it delivers strong real-world performance. Since it's difficult to evaluate object-centric reconstruction in casual setups with existing datasets, we further introduce a new evaluation dataset that provides complete 3D geometries across a wide range of categories in real-world casual sequences. We show that ShapeR outperforms state-of-the-art shape reconstruction and generation. Thank you for watching.